This is Intro to Java. We are in week 9. We are going to finish off some of our work in chapter 4. We're going to pick up where we left off, which was at the bottom of page 208. We had just created this You Do It exercise, and we are going to move on. So the first thing that we want to talk about here is what they call static fields. And you know, we've been working with various methods in a program, and just for example, I'm going to bring up something I already have on the screen here. And we look at the contents and we look at these keywords that are in the declarations for the methods. And you notice we have public, we have static, we have void, and we have learned what the void is for, right? What other possible things could go in that position? The answer is anything that you would be returning from the method. So remember, you can run a method that returns a value, and if it returns a value, you have to indicate in this position what you're returning. So if I'm returning a double or an integer or a string, that would need to be listed here. When it says void, we are not returning anything from the method. We're just running what's inside of it. All right. Then we also have this keyword, static, and that's what we're going to learn about. Now, in this little section here, and I encourage you to read it, it's pointing out a few things. One thing that's interesting, I think, is that static methods do not have a this reference because there's no object associated with them. Therefore, they are called class methods, and that's a good one to highlight. You also have the capability of creating class variables, and it says which are variables that are shared by every instantiation of the class. So in other words, I can create variables inside of a class, and then all versions of that class, all the objects created from that, can use the same variables. That's all that means. Okay. So did you guys get a chance to read up on what static means? No, not at all?
I have it now.
Okay, I jumped here to page 231, and I'm highlighting this because maybe a real succinct way to say it is sometimes more efficient, at least for understanding. And here it says that a static member class is a type of nested class that has access to all static methods of its top-level class. Now that's kind of a mouthful. Let me see if I can kind of decipher it a little bit. We know what a class file is, right? We are creating, for example, in JGrasp, we are creating, well, this is a full-blown program. All right, you can see that it is got a static void main. But here we have just a class file, and one of the ways that we can, I'm sorry, that's not a class file. Let me find my class file. And what I'm looking for is one with a get and a set. Okay, this one here actually is a class file. I was just looking at it really quick, looking for a set and a get, and I didn't see them, so I just jumped past it. But it is a class file that we can use to create a blueprint for other objects. All right, but this class file, what's interesting about it is that, first of all, you can tell it's a class because we're able to use the this reference. That's one thing. Remember, this one we were doing overloads with it. You guys remember that, where we send in different numbers of parameters, then we set up situations to deal with all of them. And what this little description in our text is saying is that a static member class is a nested class. So that would mean a class that sits inside of a different class. That class has access to all static methods of its top level class. So in other words, if this particular class file had methods within it that were static, we would be able to access them from within that. They're directly available within that same class file. That's a little out there until you actually start to play with it. So let's continue on with the discussion here, and then when we work with it, I hope that you'll get a little bit better feel for it.
I wish they had like a chart, you know, of like that could help you look at it and say, this is a class, you know, and then underneath it, then say this would be your method then. You know, I mean, it just seems like so many words you have to memorize, and then like when you say, well, what does a void mean? It's like, oh my God, I don't know.
Okay, you're right. There is a lot to bring back, and
because they say, well, the method is in a class, which is in a whatever, you know what I mean? But I wish there was like just like a little chart that said, like you know, one that is just.
Well, can you tell me from looking at this, if the thing that I'm highlighting, what is that?
That's the method.
That is a method. Okay. What about this?
That's the.
This is what we're talking about
Yeah.
here. What does the word static mean all on its own?
But it doesn't do anything.
It sits there.
Yeah. So when you do something with static, you're just giving it something to do later, or you're just giving it something, but it doesn't do anything. I mean, see what I mean?
It doesn't necessarily not do anything, but for one thing, it is available to other things within it.
Yeah.
That's kind of the key, and that's what they're doing here. All right, so in this particular example, and I'm trying to like follow through on their whole example. It says, for example, consider the baseball player class in Figure 432, which is this one. The baseball player class contains a shaded static field named count. Right? This is that field right here.
Yeah.
And the two non-static fields named number and batting average. Excuse me. The baseball player constructor sets values for number and batting average. Now, the constructor, notice what we have going on here is we don't have like a full-blown program per se, we just have a class file.
Right.
This is not a self-executing component. All right, so it sets values for the number and the batting average and increases the count by 1. In other words, every time a baseball player object is constructed, it contains individual values for number and batting average, and the count field contains a count of the number of existing object and is shared by all baseball player objects. All right, so let me see if I can clarify that for you a little bit, because I know it's a little sketchy. The way I like to think about it is we're still using this class file to create the baseball player within our program. So we're going to run a little thing inside of our program that says baseball player, we might give him a name, let's say like Jones, and then we'll say equals new baseball player, and then we're going to send in some values, and what we're going to be sending in are these things here. So in other words, we are going to bring in the number that's coming in and the batting average so that we can return those things. The count is going to be relative to the count that's happening in the main program. So notice here it's set to 0. But in order to be able to do the calculation, we need to have the current count, and that's going to be adjusted from outside this class. So this is available to everything within here, but it will change if we send something in. But static is where it starts and where it'll stay. Hopefully that helps to clarify a tiny bit. I know that some of these topics are a little bit vague initially when you first, because we're dealing with objects and classes and methods and all these things that, and they're kind of fuzzy at first. But when you start to get a handle on it, you go, believe me, one day you'll go, oh, I get it. Because that's how it was for me when I first learned it. And it's hard to explain it initially, and that's why I put so many different resources out there for you guys, that maybe if you hear somebody else explain it, you'll get it a little bit in a different way where it'll latch in. So.
Well, that's like when you asked me what that was, and I knew it was a method. I don't know how I knew that, but I guess it's from.
I must have taught you well.
I'm just saying. So eventually, a person will go, oh yeah, that's right. So I'm starting to get it, and I'm starting to understand it. I just wish they had just generic form, that said, this is what you do here. Sometimes it'd be a little bit easier.
Yeah, unfortunately, I don't think it's always so clear cut that they could just stick it in a table.
I think when you're doing it, and then you're realizing, wait a minute, no. Because a lot of times, when you're working on it, even though you're following along and just what the book tells you to do, and you're like, what does it mean? Why is it saying that? And then when you do it, it's like, oh, I get it. Because if I don't do it there, and I put it there, that's not right then. Then that would
right. Well, that's part of it, but following what they're doing doesn't necessarily mean you're going to understand it. So,
okay.
Well, let me continue on with their example here, because I think it'll help to clarify it. So let me just go back up here, and they say, it says, in other words, every time a baseball player object is constructed, and remember that's happening outside of this class in your main program somewhere, it contains individual values for number and batting average, and the count field contains a count of the number of existing objects and is shared by all baseball player objects. So in other words, maybe a better way to say this is every time the baseball player is constructed, in order to get a batting average, how do you do that?
You call in the method or the class.
I just mean in terms of baseball. How do you get a batting average? Right?
I'm sorry,
If you're up to bat and you can get on base, that's positive. Okay, so that's a true. I got on base.
Right.
If I don't get on base, it's a false. It's a 0.
Yeah.
So if I get on base, every other time I'm at bat, so one time I don't, one time I do, my batting average is 500. Now in baseball, that would be fantastic. In baseball, if you get 300, that's fantastic. So less than 1 out of 3 is considered really good in baseball. So you'll come up to bat 3 times or 4 times. By the 4th time at bat, hopefully you're getting on base. So if you get on base 1 out of every 4 times, it's 0.25, 25% of the time. So that's what a batting average is. So what they're saying is every time we do this baseball player object, that count will be available, and it says that the count field contains a count of the number of existing objects, and that would be the number of baseball players, and it's shared by all the baseball player objects. So in other words, in order to really be able to calculate that, we need to have that value sitting out there, not changing. We're adding to it, but that way we can do the math and have it be accurate. I'm not sure if I can say it any more clearly than that. So, all right, so here, just continue with the example. They're saying the show player method in the baseball player class displays a baseball player's number, batting average, and a count of all current players. This method is not static. It accesses an individual object's data, It says methods declared as static cannot access instance variables, but instant methods can access both static and instance variables. Now, I think this is one thing that you'll see in action, because what they're doing here now, this is the example of the actual program that's calling that class. So you can see what's happening is we have our main method, and then inside here we are creating new versions of baseball player, and one's a catcher and one's a shortstop, and then each one of them we declare a new baseball player. We send our data over. This data is, I'm trying to remember what that's for. Oh, that's their player number. Okay, so this person wears a 12 on their shirt. And then this is their current average. All right, so we're going to do that for each player, and then we're going to show the player, and when we do the show player, it is going to player number 12, batting average is whatever it is, and there are a count of so many players. So I was kind of misreading this a little bit, but what they're counting is the number of players. So we can send in all the information we want and create as many baseball players as we want, but every time we do that, the counter inside this class will increase by virtue of doing this. So we're going to send in the number, right? So number 12, their batting average, let's say it's 281, whatever it was, and then we switch that into number. The batting average equals average, and then we can output those things. But notice the one thing that it does do is it increases the count by 1. So the net result of that is to keep track of how many players we have. So here we have a catcher, we have a shortstop, right, and their information comes out. Batting average, there are 2 players. Batting average, there are 2 players. Okay, so that is these 2 lines. These 2 lines generate these 2 lines. But notice that before we did that, we ran this. So what it's telling you is we're creating the baseball player, creating another, so now the count is 2, and then we're going to show them. So we're showing player number 12, that's the average, 31, that's the average, but there are 2 players. And the reason there's 2 players is because we created the players prior to showing the information. So in other words, if I took this line and put it above the second line here, the first line would say there are 1 players. Now to show you that that is working, here we're adding another player. That's a fantastic average, so is that one actually, so that's not likely. And then we're going to do another show player, so that says 3 players. Then we're going to show the catcher again, and that's 3 players. So it's showing you that the catcher maintains its attributes. So in other words, even though we're sending other stuff in, that object that created the catcher still has a number of 12 and still has an average of 218. The count is at 3 because sure enough we did 1, 2, 3 baseball players. So it's, you know, it's kind of a convoluted way of kind of telling you that we're creating an instance. So we're using our blueprint, we're creating a player. That field that we have inside there that's keeping track of the count, we're able to change that from within, but still create new copies of the player. Maybe that helps clarify it, I don't know. All right, let's keep moving on here. The one thing that we learned a while back, and it says here, is that we learned the keyword called final. And final is the way that we create constants inside Java programs. All right. Now, we can add to any variable declaration here the word final, and when we add that word final, we are saying this value cannot change. It will always be the same. A naming convention for constants, and it's true in many languages, is to use all uppercase so that when you're looking at your code, you can just identify, oh, that's a constant. Okay, so they try to do a little bit of a comparison here between the use of final and static. And you can look at the little paper clips. I think those are helpful. It says you can use the keyword final with methods or classes as well as with fields. So in other words, anywhere where you're assigning a value with something that is given a name, a variable, or in this case a constant of some sort, you can use the word final, which locks it in. And it says fields that are final can also be initialized in a static initialization block. And they're going to talk about that a little bit later in the book. All right. I think what will be really helpful here is to actually go through the process of working with these so we see what happens. So let's go ahead and build this exercise here. All right, so let's go ahead and create the beginning part of the program. So I'm just going to copy this. We're going to come to JGrasp. We are going to create a new file. I'm going to paste that in. All right, so we got a class named Dog Triathlon Participant. We have two private variable declarations. Notice one says final and one says static. Both are integers. Notice the one that's final is all uppercase, so that's a constant. And then the other one is assigned a value, a starting value of 0, and that one's called total cumulative score. Then we're going to add all of these private fields as they're asking us to do, so let's go ahead and do that. Now, I don't mean to skip ahead too quickly here, and I apologize if I'm doing that. They are telling us basically what this is about. So it says, create a class for the Riverdale Kennel Club to demonstrate the use of static and non-static final fields. The club enters its dog in an annual triathlon event, which each dog receives 3 scores in agility, conformation, and obedience. So that's what all these fields are about. They give them score, they total things up, and then they also create an average. Now, when we go through the process of creating a constructor, we need to use the inputs in this fashion. So if you notice, they have one for the string, the events, score 1, score 2, etc. And those all correspond with what we see here. So we need to be able to send in the name, the score, and the total, if I'm reading that correctly. Okay, so that's not exactly correct. What they're doing is they're sending in the name, they're sending in the number of events they were in, and then the 3 scores that they accumulated. All right, and let's see if they tell us where to put this. Constructor class requires 5 parameters. Okay. All So let's go ahead, put those in. And we can only assume that they want them right here, so let's do that. And then keep in mind that these are all part of this method right here. Those all work together. All right. And then we're going to continue on by doing some math with all that information. So if we're going to be calculating the total score, we need to add the 3 scores together. And then we're going to calculate an average. And then we're going to give them a total score of all the scores. So that's what this is doing. So this will be called, it will construct, it will take the name, number of events, the 3 scores, it's going to assign the name, it's going to do a little bit of math, and that's really about it. So that's what that's going to do. Now, let's keep moving on here. Next we're going to put in a method, another method, and this one I think is pretty obvious what it's going to do given its name. So this one is going to give us a little bit of output to the screen. And I really dislike the way they do the output on these because you have to like split it over several lines. So you don't have to do it the way the book does it. They do it like this because they don't have enough space. But you know, just for example, this is all one line really, and then this is all one line. So this class is going to receive information. It's going to construct a new dog triathlon participant, and then it will also do some output of that information, just to help clarify it. It says add a closing curly brace for the class and save it as follows. I think I have enough here. Yep, just one more. Let's go ahead and save that. Okay, let's also just compile it and make sure everything's okay. All right, and it compiled just fine. Remember, this is not an executable program. It is a class that we use to build objects. All right, so now we're going to create another new file, and I'm going to grab the skeleton structure here. So let's go to JGrasp again. Let's do a new Java. Paste in. And notice this is actually a complete structure for a program, right? We got the public class, we have our main, and notice I'm going to keep indenting this stuff, try to keep it somewhat neat. All right, that should work. It says between the braces of the main method, declare a participant object, provide values as described. So let's just go ahead, copy and paste. So now think about what's happening here. Very much like we've done with some of the other things, is we basically are creating a new version of dog triathlon participant, which is, this is our blueprint for it. Okay? So we're creating a new version of that. We give it a name, so that the version that we're creating is called Dog 1. I'm going to see if I can save some space here, because they paste in so many spaces for some reason. we use the keyword new. And you can see we're sending in the dog's name, the number of events, one of the scores, what are the scores, and a different score. And I'm really truncating it on purpose, so it fits on the screen. So we got 1, 2, 3, 4, 5 things that we're passing in to the class. When it gets to the class, where is it going to go? It is going to come in, and it's going to come into these spots here, all 5 of them. Then it's going to manipulate it, and assign those values to all the variables that we have set up. Then the next thing that's going to happen is we are actually going to do a display. So this new object that we created, which is based upon that blueprint named dog1, we are going to do .display. So when I do dog1.display, dog1 is an instance of this class, so it belongs to this class, and because it belongs to this class, we can invoke all of the methods that go with it. One of those methods happens to be display. So when we say this, we realize that this, because it's built on this blueprint, has all of these capabilities. So when we say dog1.display, it will come here and display. All the values for it have already been set by virtue of sending in these values, and then it will just do the output.
But how do they know to talk to each other, the two? Because you're using dog triathlon participant,
Right? That's the class name.
so then you're calling that class, eh?
Yeah, well, when we do this part, when we do a new one,
Yeah,
we're saying that, okay, whatever that is, we're copying it.
yeah,
We're sending in this information so that it will be unique to it. So in other words, all of the things that we have up here
Right.
that need values, those will be populated. So it will have its own identity, dog1,
yeah.
and all these things will be set. And dog1 does all the same things as this, and that's why we can just say dog1.display. That will run this display method
Right.
and output all the things that dog1 has as values. Hopefully that makes a little
Yeah,
sense.
no, it does, yeah.
Okay. So let's see here. So we did this one. Now let's go ahead and do the next 2. We got 2 more dogs. I probably won't be as neat with the formatting on this, but although it would be nice if I was. And what I'm doing here is I'm just indenting so you can see that the lines really are the same. And you can clean it up as you see fit. So dog1, dog2, dog3, so we got Bowser, Rush, and Ginger. Here you see all their scores, the number of events they're in. And then we have 3 different copies of that class. Let's see what our next task is. Save as test dogs, compile and execute. So let's see if it works out. So let's do a save. Let's compile. No problems. Let's give it a run. You can see our output here. It should look like what we see in the book. So here it says Bowser participated in 2 events and has an average score of 87. The total score of 174, bringing the total cumulative score to 174. So it looks like what they have on the screen, so I think we did just fine. But the key is here that we have 3 different versions. We are able to access all these variables that we're sending in, each one starts out with a total cumulative score of 0. And the reason that's important is because we are doing math with it, that we preset it, just so we don't get some junk in there. And then everything else, really, we're sending in. And because this little tidbit will change each time we create a new dog, that's why it's static. So it stays at 0. We do the math, and when we create the new copy, that's where the value goes. It goes with the new copy. Now you can feel free on your own to complete the last part. It just plays a little bit with some of the values. And they're also trying to teach you a new concept here. If you see this, NaN stands for not a number, meaning that you're putting in a value that's not a number into a field that's expecting a number. So if you see that, that's what you can do that. Now it does give us a little bit of a hint here that in the next chapter we can prevent that from happening by using basically an if statement of some sort to check to see if it's not a number, then don't do it, or do it. Right? Because if you need a number to do math and you send in a letter, it's not going to work too well. That's the point there. Now, Java is a cool language because of a lot of what we see here. And the neat thing about creating a class file that allows you to create new objects is the fact that once it's created, you can reuse it. So if you create one program where the dog triathlon participant is useful and you have another program that's similar, you can just pick up that class and call it from this other program. So what they're talking about here basically is all the classes that are actually pre-created for you and the ability for you to pull those in and use them as you see fit. Now they're giving a few examples here. So they're telling you that there is a library of classes in this little collection here. And I'll highlight it because it gives me something to do. So how does it work? We don't want to remember the number for pi. I happen to be one of those geeks that remembers it probably to too many digits. But usually for most basic math, if you do 3.14, you're close enough. But it is a constant number that goes on to infinity and never repeats. Pi, it's an interesting number. But inside this library, javalanguage.math, they've preset the value for pi, so when we want to use pi, we don't have to go looking up the number, we just use its name. So inside that class file that contains its definition, this is what you'll see. You'll see that pi has a definition that says it's public, it's final, that means it can't change. It's static, meaning we can't alter it within itself. We can alter a value using it. It's a double because it's got decimals, and its name is pi. And they go through the description here. So they say public, any program can access it directly. Final, cannot be changed. Static, and this is maybe your table that you're looking for, Kelly, only one copy exists and you can access it without declaring a math object. And then double, so it holds a floating point value. Then they give you some examples of how I can just call the library, see, and I use the syntax java.language.math.pi. And what that does is it goes to this library, it finds pi, which is this, and then it uses it to do math. Now the neat thing is because we're already importing the library, depending on how we do our import, this little tidbit here does not need to be necessarily included in the declaration. So, because we're pulling in the library, all I need to do is say math.py. Now, the reason we're pointing that out, and I'm looking for the spot where they introduce it here, and apparently it's not on this page. But there are a number of different mathematical functions that are built into just about every programming language, mostly for things, for formulas and for values that we don't want to sit there and remember, but are common ones that are used. And, and these are just some examples.
So, the arc tangent of...
All right, so these are some of the, math methods that are built in. And since math is used very commonly, you can, for the most part, just call upon it in this fashion, as long as you know the name of the function. Of course, there's great lists out on the web of all the different math functions that are available, but chances are you probably won't use any more than what are shown in this book, with some exceptions. All right, so another thing that you guys have done as we've worked is the fact that we can import utilities and import libraries and import classes, and you'll see that at the top of a lot of the documents we've created, and I'm pointing out this one, right? And you can see in this one we are pulling in the scanner, but it's also possible to actually use the wildcard symbol, and you can have the ability to pull in everything that comes inside that collection of classes that they've created. All right. They do a little bit of a demonstration here on how to use the Gregorian calendar class. I'm not really too concerned about talking about it in detail, but please feel free to go in there and play with it. And they have all these different little arguments that you can throw in. Now this is useful, of course, if you're doing calculations for dates, or if you're creating a program that will manipulate dates in some way, or store them, or read them to make some sort of a determination. And like I said, you feel free to go ahead and play with this. With this particular you do it exercise here on page 221, I am also going to kind of skip over this. I'm assuming you guys have the capability of going through there and copying this down. And it's really more to show you how the calendar thing works. It's not a big deal. Just a matter of putting all these things in. But there are all these different ways of doing things, and the only way to really get it is to play with it. So that's what that's all about. And it's kind of a lengthy one, so that's one of the reasons why I'm kind of jumping over it. Now we have one last concept in this chapter here to talk about, and I'm going to try to get through this one fairly quickly too. Probably skip the you do it on it. But there's these two key concepts. One is composition and one is nested classes. All right, so here as far as a definition goes, it says a composition describes the relationship between classes when an object of one class is a data field within another class. So that's kind of a little fuzzy in its definition. All right. It says you may have already studied many classes that contain string object fields, and these classes employ composition. So what it's telling you is, for example, a string is really a class, not a data type, but we use it as a data type. Or at least that's a component of it. So they use here, for example, this concept of the relationship, and I like whoever thought of this, of course, is really brilliant, because the relationship created is sometimes called has a relationship, because one class has an instance of another. So the point of that is that we can do something like this. Now look at this really carefully and tell me if you see anything weird here. See anything weird with this class? Okay, you see anything weird with this? No, I mean, it looks like a normal method, right? Do you see that it has this here as well? Right. But we're using this one to compose or indicate that there is a relationship between this one here and the one that contains it. So this actually kind of leads us into the next little topic, which is nesting. I told you I'd go quick. So it says in Java you can create a class within another class and store them together, and those are called nested classes. The one that sits topmost is a top-level class. All right, so then they go through a definition here of the 4 different nested class types, and I'm not worried about you memorizing this. But static, once again, says a member class has access to all static methods of the top-level class. So if I create a class inside of a class and I call it static, it is able to access all the other ones within it, within that top-level class. Ones that are non-static are inner classes. They cannot access stuff inside of other ones, but they can access everything inside the top level. All right, local is only accessible to itself, and then there's anonymous, and we haven't really talked about that concept in this class, but an anonymous class is one that doesn't have a name. So how on earth would you use that? Well, you would use that within a function itself. So in other words, you might call a thing and it just does something, but whenever you're calling on it, it's always within something else. So you really have no reason to give it a name because it's already doing it within itself. So I'm trying to think of a tangible real world example for it, but let's say I create a class that does the dog thing. Okay, so we create a class that we send in the name and the weight and the breed, right? And then inside that, there might be a separate thing that would do eye color somehow. And I'm just stretching here. And that just happens automatically within it. And because it's happening automatically, it doesn't need a name because we don't have to call it. It just happens. So those are called anonymous classes. All right, and I think that's all I'm going to cover here. So we're going to wrap Chapter 4. Please feel free to do the rest of the you-do-its, but I've covered all the topics, and we're going to pause this video here, actually end this video here, and take a break here in class.